Hi, this is the first lecture for Chapter 3. Chapter 3 is about exponential functions. We're starting with Section A on page 82. This is just an expression. I'm sure you've seen something like this before. It's an exponent, and we're just going to review that a little bit during the next couple sections. 4 to the third power, if you remember, is equal to 4 times 4 times 4. And maybe you can't do that in your head, but if you group it a little bit, say 16 times 4 is 64. And if you have trouble with that, you can use your calculator. 4 to the third power, and we get 64. Okay, so we confirm that value. It says to label the parts of this equation: base, exponent, index, and power. Let's see. The base is the bottom of the exponent, okay? And the exponent is this part that's at the top. And the index is the same thing. This is also the index. And the power is also here. So exponent, index, and power, those are just three ways of saying the exponent. And the base is the bottom part. Okay? Exponents help write expressions which represent repeated, and what multiplication, or what operation are we doing here? Repeatedly, it's multiplication. For example, in the above expression, 4 is multiplied 3 times to get 64. Okay? What is the difference between these two exponents? And it gives us a negative 3 to the fourth and a negative 3 to the fourth. And I've seen many people in both math classes that make this mistake. Just remember PEMDAS. So if the parentheses are first, then that means the negative 3 is going to be taken to the fourth power, which means you have to multiply negative 3 4 times. Okay, so this one would be negative 3 multiplied together 4 times, all right? And then this one, where the negative is outside the parentheses, the 3 would be multiplied together 4 times. And then after you do that, then it would take the negative. So you can see that, like in this case here, since it's a negative number multiplied together 4 times, the negative would end up multiplying times each other and getting rid of it. In the end, the answer is going to be a positive number, right? And 3 times 3 times 3 times 3 is actually 9 times 9, which is 81. And this is going to be a positive 81 because the negative multiplies itself into a positive. Now on this one, after you get the 81, then you're going to take the negative of it. So the answer to this one is actually negative 81. The answer to this one is 81. So you can see the difference there. Whenever you have a negative number for the base, depending on the exponent, you might get a negative number, you might get a positive number. And then I ask, what is the meaning of this expression here, following the rule of PEMDAS? And so this is a little bit harder than the parentheses example I gave you before, because the parentheses always come first. It makes it obvious what the results are for the above two. Now here there's no parentheses, so then you really have to use PEMDAS. The second operation you do after parentheses is exponents. So in this case, you would do the exponent first. So 3 to the fourth is 81, and then you would take the negative of that, so it would be negative 81. Okay? So just be really careful with that. Whenever you have an x to the fourth and you're going to plug in like x equals negative 3, that means that it's going to be negative 3 to the fourth. Okay, you have to, everything you're going to put in the x needs to go into a parentheses. I've seen a lot of people make the mistake where they just write it like this and then they think that the negative goes in last, but it actually needs to go in parentheses when you substitute in for x. When x is 4, the expression negative 3 to the x yields a positive answer. So negative 3 to the fourth gives us a positive 81, like we mentioned above. For what values of x would the expression yield a negative answer? Well, let's see. What about negative 3 squared? Does that give us a positive answer? No, that would give us 9, right? What about negative 3 to the 0? That gives us 1. What about negative 3 to the 1? Oh, that gives us negative 3. What about negative 3 to the third? We didn't try that yet. That gives us negative 27 because it's negative times negative times negative. That gives us a negative. So you notice that if you have an odd number of negative numbers multiplied times each other, you end up with a negative number. So you can see that like 1, 3, 5, 7, odd exponents are going to give you a negative answer. So the answer here is that for odd x's, it would give us a negative answer. Okay? All right, now let's do a few problems since we got some time left here. I'm just going to try to take the last one of each to give you the hardest one. List the first 6 powers of 3. Well, 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3, etc., all the way to 3 to the 5th, right? Because it says the first 6 powers, the first power is 0. So let's see, that would be 1, 3 to the first would be 3, 9, 27, dot, dot, dot. And the last one would be 3 to the 5th, which would be, I think it's like 283. 3 to the 4th, as you remember, is 81. 81 times 3 is, oops, I'm sorry, it's 243, isn't it? 243. Okay? All right. Copy and complete the values of these common powers. Let's just take the last one of each just to do the trickiest one. So 5 to the 4th would be 5 times 5 times 5 times 5, which is equal to 25 times 25. You can use your calculator to do that, but I already know that that's 625, so you can check that with your calculator. 7 to the 3rd is equal to 7 times 7 times 7. That would be equal to 49 times 7. That's about 350. It's a little bit less than 350, actually. It's 343. Okay? So you need to do all the powers, but that's the biggest one. Simplify, then use your calculator to check your answer. So let's take the last one here. Negative of negative 2 in parentheses to the 6th. So let's see. That would be negative 2 times 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 negative 2. I'm sure you're going to do this a better way. When you multiply negative 2 times itself 6 times, you get, let's see, 4 times 4 times 4, which is 64. Now, is it positive or negative 64? Well, the negative 2's will multiply themselves into a positive 64, but as you notice, there's a negative in the front, so it ends up being a negative 64. Okay? So the answer to J is negative 64. What about number 4? Use your calculator to find the value of the following. Record the entire display. Okay, so let's turn on our calculator, and we'll do 8 to the 6th, and we'll get 262,144. 262,144 is the answer for E. Okay. And on these, I'm asking you to do them all. I already cut some out, as you can see. Okay, so these two here, let's see. We'll do the negative 2.13 to the 9th. So we'll do, make sure you do the parentheses. Oops, I don't know if this should be a negative or subtract, but negative 2.13 parentheses to the 9th power. Okay, so that's a very complicated number. Negative 902.4360396. Okay, so to give the whole calculator display for that one. Use your calculator to find the values of the following. So let's do this one here. 1 over 6 to the second. 1 divided by, and then we need to be careful here just to make sure that with PEMDAS that everything works out. You know, since exponents are done first, we don't really need a parentheses here, but you know, if you prefer not to think so much about it, go ahead and put it in. So that would be 0.02778. Yeah, I rounded that up. Normally in IB we give 3 significant figures, so I'm going to put an 8 there. Okay, let's do this one. 0.366 to the 0. Anything to the 0 power is 1. So that's 1. Let's see. Calculator practice. Program the equation y equals 2 to the x or 7x in the calculator with the key y equals. Then look at the resulting xy pairs by pressing second table. Okay, so it's saying look at all the powers of 3, look for a pattern, and find the last digit of 3 to the 101st. What is the last digit of 7 to the 217th? So let's do the hard one. We'll do this one. Okay, so we're going to use the calculator to do this. So we're going to put an equation in here, and maybe you've never done this before, and if so, you're going to learn something very useful. We'll do 7 to the x, and then we're just going to see what the values are in a table, and obviously 7 to the 0th is 1, but 7 to the 1st is 7, and 49, 343, and so on. Now, what is 7 to the 217th? Well, if you wanted to, you could like go down this table and actually find 7 to the 217th, but what they want you to do is they want you to see the pattern in the last digit, because all they're asking for is the last digit. So the last digit of the 0 power is 1. For the first power, the last digit is 7. 2 is 9, it's 49, right? 3 would be 3, it's 343. 4 is, the last digit is 1. 5, the last digit is 7. And then you can see that it starts to repeat, right? So the cycle is basically 1793, and then it starts over again. You can see that for 6, it's 9 again. So it's going to repeat. And so now what we need to do is we just need to figure out is, well, what's the last digit going to be when it gets to 217? We know that it's a cycle of 4, and let's see, if we have 217 is actually the 218th number because the first number is 0, right? And 218, we'll check if that's a multiple of 4, because if it's a multiple of 4, and it's not, then that would be the last number in the cycle. Since it's not a multiple of 4, it appears to, probably the multiple of 4 would be 216. So let's see, 216 I think is a multiple of 4. Okay, so to the 216th number would be exactly the end of a cycle. Okay, so the 216th number would be 3. And then the 217th number would be 4, I'm sorry, not 4, 1, right? The next number in the cycle is 1. And then the 218th number, the last number would be 7. So, and actually 217 is the 218th number, remember, because 0 is the first number, okay? So we would predict then that the 218th number, or the 7 to the 217th, the last digit is 7, okay? And then last of all, this is a very interesting historical note about how the behavior of the third power behaves. And that's it for today. See you in class.